So we have taken an example discussed previously called the watering system, and we want to now demonstrate the entire thing through a MATLAB software. Fuzzy logic toolbox provided by MATLAB provides functions, applications, and a Simulink model for analyzing, designing, and simulating systems based on fuzzy logic. A very powerful tool. So we use the demo to see how the fuzzy inference system works using the fuzzy logic toolbox and the user interface tools. These tools support only type 1 fuzzy systems. You will see the tools to build, edit, and view fuzzy inference systems. So for instance, the fuzzy logic designer. This is used to handle the high level issues for the system, like how many inputs, how many outputs, what are their names, and so forth. The membership function editor, another tool or subtool, this is used to define the shapes of the membership functions associated with each variable. Remember the triangular, trapezoid, and so forth. The rule editor. This is used to edit the list of rules that define the behavior of the system. Then there's a rule viewer as well. So to view the fuzzy inference diagram using this viewer as a diagnostic tool, for example, with rules are active, which rules are active, and how individual membership function shapes influence the results. There's a surface viewer as well to view the dependency of one of the outputs on any one or two of the inputs, and it generates and plots typically a 3D view output in a surface map, so you can actually really understand how things are depending upon each other based on the inputs. So if you change the names of for instance, the membership functions in the membership function editor, the changes are reflected in the rules shown in the rule editor. So they are interconnected in that sense. Right. So now to open the fuzzy logic designer, on the command prompt, type fuzzy. Okay. Then select the fuzzy inference functions for the AND operations, OR operations, implication, aggregation, and defuzzification. Okay, now there are two inputs and one output of this system. The inputs are temperature and soil moisture, and the output is duration. As mentioned earlier, the fuzzy inference system uses OR, okay, method for max. For implication, we use the minimum. For aggregation, we use maximum. For defuzzification, we using the centroid, are used for this demo. So for defuzzification, it's the centroid. Now, let's set the membership function for inputs, temperature and soil moisture, and the output duration. The range of input membership function is 0 to 50, and temperature has 5 linguistic variables already discussed: cool, normal, warm, and hot. Okay, as you can see, the triangular membership function trimf is used for inputs as being shown. Okay, moving on, the soil moisture membership function is divided into 3 linguistic variables dry, moist, and wet, and they are therefore in front of you. So the dry has a particular uh, behavior, and the moist, and then the wet are typically straightforward. We have not chosen any complicated kind of things. Okay. As duration has three linguistic membership functions such as short, medium, and long, and the range defined for the output is from 0 to 90, like which is minutes. So you can see the short range, the medium one, and the long one. In rule viewer, we can see the inference of rules against the input provided as shown. In rule viewer, we can see the inference of rules against the inputs provided. As you can see, you can move around and see the behavior, the effect of the temperature that results, and so you can see those vertical lines, and then because of the soil moisture as well. As we did, remember in the previous example as well, when we did a MATLAB study before. So you can move around and see the impact of each of these, okay, and then look at the duration as well. Now there are three rules are defined. Okay, the first three. The rules are if the temperature is hot, any one of them. Let's say if temperature is hot and soil moisture is dry, then duration is long. If temperature is cold and soil moisture is dry, then duration is long, and so forth. Okay. Now, as against each of these, we can see the behavior of the system. So having done that, having seen the rules, now we look at the most interesting part, the surface viewer. This is a 3D interpretation between temperature and soil moisture inputs with the corresponding output, which is duration. If you look at it carefully, initially it doesn't make sense and apparently difficult. But on the x-axis, let's say we place temperature from 0 to 50. On the y-axis, on the left side, we have the soil moisture that is between 0 and let's say 70. The vertical z-axis, we have the duration. So very simply, if you look at, let's say, temperature being very high, meaning let's say at 50, okay, if the temperature is at 50, then the duration, okay, is just about 60, 70 maximum. So greater the temperature, greater the duration. So you'll need longer to actually give more time to the water. And then likewise, you can see, let's say, if the moisture, now coming back to this one again, if you see on the moisture side, if the moisture is maximum, which is like 70, then virtually there is no duration, there is no water, almost zero. Just to give you, the two extremes here. And then there are other combinations as well. And you can turn around and see the various effects to understand the actual behavior of how various inputs, they result in the duration that is required. And that is given by the vertical axis, which is the z-axis of the duration. That is really the result that you are looking for. So various combinations, as you can see. Now surface viewer, another interpretation between temperature input with respect to duration, as you can see, just two. So on the x-axis is the temperature and vertically is the duration. And as you can see, starting with, let's say, the temperature between, let's say, almost 4 less than 5 degrees, okay, the duration is very high, and then is almost constant as long as the temperature is increases, okay, the duration remains around about 30, 35 and so forth. Interpretation between soil moisture and input with respect to duration. once again you can see the effect, and that's also demonstrated by that single two variable outputs. So, greater the soil moisture, the smaller the duration of the water that is required. Now, the interesting thing is, and towards coming to the end, you can also check this system with hardware integration. Very interesting. So, now that you've built the system, you can actually integrate it with the hardware, and by following the GitHub website, you can actually go there and demonstrate and test the system out. In this plant monitoring system and irrigation system project, the device will measure the soil moisture and temperature every, let's say, 30 seconds. Then the device might turn on the water pump for the calculated duration based on the fuzzy logic method that you used, depending on the measured soil moisture and temperature. All of these measures or measurable data can be published to the cloud. Right. So, having done this demo, okay, we have actually learned what the issues are, how to implement, and then how to actually develop and view the results. So, the device, as mentioned in the demo, that actually measures the temperature every 30 seconds, and then the system, using the logic of the fuzzy system, decides whether the water has to be switched on or not. It can be 0, of course. Okay. So, I am sure you have found this interesting and understood how the actual systems work, and that can actually be connected and demonstrated if you want to go further ahead. So, thank you very much. We will see you next time.